Today we are going to do a review of all of the properties of exponents that we have talked about so far last week. So the first one is multiplication with exponents. So if you remember, when we are multiplying and we have the same base, this only works when we have the same base, and in this case we have bases of 3 that we can just add the exponents. So we're going to keep the base of 3 and then we're going to add the exponents. So the exponents are both 2, so 2 plus 2, we end up with 3 to the 4th. We can simplify 3 to the 4th by doing 3 times 3 times 3 times 3. So 3 times 3 would be 9, this 3 times 3 would be 9, and 9 times 9 would be 81. But sometimes there's going to be an extra step when you're doing these. So this one, y to the 3rd times y to the negative 5th, we're going to keep the y, and we're going to add the exponents. So 3 plus a negative 5. If I add 3 and negative 5 together, I get a negative 2. I can't just leave with a negative exponent. I have to have all positive exponents in order to be simplified all the way down. So if you remember, when we have a negative exponent, we automatically make a fraction. We put that y at the bottom, and then our exponent becomes positive. Moving on to division with exponents, we are going to subtract the exponents. So in this case, we're going to keep the base of 5 and then subtract the top exponent minus the bottom exponent. And 9 minus 7 is 2, so we have 5 to the 2nd power, which is really 5 times 5, and 5 times 5 is 25. And in this one, we can only subtract where the bases are the same. So we are going to do u to the 5th, and we're going to subtract that 3, so we get u to the 2nd. So what I had circled there simplifies to u to the 2nd. So that would be at the top. This 2 squared over here has nothing to simplify with, and it's at the bottom, so it has to stay at the bottom, but 2 to the 2nd power is 2 times 2, which is 4. So we're going to leave that at the bottom in the simplified version. And that would be our final answer. When we have a product of powers, we are going to multiply these exponents. So we have the base of x, and then we have an exponent of 2 and an exponent of 3. So 2 times 3 makes x to the 6th. Down here, we have h to the negative 2nd, and that raised to the 5th power. So we're going to keep the h, take negative 2, and multiply it by 5. That gives us h to the negative 10th power. But we can't have a negative exponent. We have to simplify all the way down. So whenever there's a negative exponent, we have to make a fraction if we don't already have one. So 1 over, keep that h, and that exponent of 10 becomes positive. Moving on to negative exponents, we're given 1 over y to the negative 5th. So like I said before, whenever there is a negative exponent, we automatically think fraction, but we already have a fraction here. So what I'm going to do is notice that the negative exponent piece is at the bottom. I can't simplify anything. I can't do anything with it. So in order to make it a positive exponent, I'm going to move it to the opposite spot in its fraction, and the exponent will become positive. So I'm going to end up with 1 times y to the 5th power at the top, and then there's nothing left at the bottom, so now I don't have a fraction. And 1 times y to the 5th would be y to the 5th power. Our next one is starting off with x to the negative 1st over x to the negative 4th. So if you remember, we have to subtract exponents when we're dividing. So I'm going to have x to the negative first minus the negative 4. And recalling back to 7th grade, minus a negative actually turns into a plus. So I have negative 1 plus 4, which is going to be x to the 3rd power. And here we have 1 over negative 3 times g to the negative 2nd. So I can't simplify. 1 is the only thing in the numerator, so I can't combine anything. But I do notice that I have this negative exponent. I have g to the negative 2nd exponent. We're not going to include the negative 3 with this because g is the only thing with a negative exponent. And to make that exponent positive, we're going to move it to the opposite spot in the fraction, and it will become positive. So I will have 1 times g to the 2nd power at the top. And that negative 3, I can't do anything with, so it gets to stay at the bottom. I can simplify the top. 1 times g to the 2nd power would be just g to the 2nd power, and our negative 3 stays there. And for a mixed review question where it has a couple of different things that we have to look at, I have 4 to the 11th power over 4 squared to the 6th power times 4 to the 4th power. So in the order of operations, you are always told to look at parentheses first. So that's where my eyes go straight to, is right here. So 4 squared to the 6th power is going to simplify to actually 4 to the 12th power because we have to multiply those. So then I'm left with 4 to the 12th times 4 to the 4th at the bottom. Multiplying with the same base, I'm going to have to add those exponents. So I have 4 to the 12th plus 4 would be 4 to the 16th power. So after simplifying my denominator here, my new problem is going to look like 4 to the 11th over 4 to the 16th. And then the rule with division with the same bases is that we have to subtract exponents. So we have 4 to the 11th, and remember, always start at the top, minus 16, which leaves us 11 minus 16 is negative 5. I can't have that negative exponent. It's not a fraction already, so I'm going to make a fraction. And 4 to the 5th with a positive exponent goes at the bottom, and that would be your final answer.